Hi, Assalamualaikum and good day everyone. So today we are going to continue with lecture 3 of chapter 5, which is we are going to focus on subtopic 4.3, inverse of matrices. So the learning outcome for this lecture is at the end of the lesson, students should be able to compute the inverse of non-singular matrix using adjoint method and AB equal to KI method. Finding inverse by using adjoint method. So the inverse of a matrix A is denoted by A inverse equal to 1 over determinant of A multiplied with the adjoint of A, given that magnitude of A must not equal to 0. So for every non-singular matrix, the determinant will not be equal to 0. Okay? Singular matrix will have determinant equal to 0. So please remember that. If determinant of A equal to 0, A is a singular. So the inverse does not exist. So the inverse only exists for non-singular matrix where the determinant is not equal to 0. So inverse of a matrix of 2 by 2 order. So let A equal to A, B, C, D. Then by using adjoint method, A inverse is given by A inverse equal to 1 over determinant of A, which is AD minus BC, and then the adjoint of matrix A. So what it means by adjoint matrix A? So this is the inverse for 3 by 3 matrices. So let C be the cofactor of matrix A. Then adjoint of a matrix A is defined as the transpose of cofactor matrix. That is adjoint A equal to C transpose. Okay, so now you understand what it means by transpose. So let's do some example for 2 by 2 matrix. So find the inverse matrix for A equal to 3, 1, 5, 4. So we have directly the formula A inverse equal to 1 over AD minus BC multiply with the matrix of D, negative B, negative C, A. Okay, so A inverse equal to, what is the adjoint? AD minus BC. So 3 multiplied by 4 minus 1 multiplied by 5. So we have, and then we multiply with the adjoint of A inverse, which is D, negative B, negative C, A. So we get, what is our D? D is equal to 4, negative B is equal to negative 1, negative C is equal to negative 5, and A equal to 3. So how do we get this? If this is your adjoint of matrix A, what is adjoint? Adjoint is cofactor transpose. So how do you get cofactor for this matrix A? You get the minor with the sign of plus, minus, minus, plus. So what is the minor for this matrix A? So we delete for the first row, first column. So we get 4 here, and then delete here we get 5, and then delete here we get 1, delete here we get 3. So your cofactor is equal to 4, negative 5, negative 1, 3. So for adjoint of matrix A, so we have cofactor transpose. So transpose this matrix. So cofactor transpose. So we have this row as a column. This second row as the second column. So we have 4, negative 1, negative 5, 3, where 4 is D, 3 is A, and negative 1 is negative B, negative 5 is negative C. So we can directly use this formula for 2 by 2 matrices. So it's actually, this formula is come from the adjoint matrix method. Okay? So I just want to revise back how do we get this formula from the adjoint method. So now we have the adjoint here for negative 1, negative 5, 3. Now the determinant is equal to 2. 7. 12 minus 5 is 7. So 4, negative 1, negative 5, 3 multiplied with 1 over 7. This is our inverse. So the final answer for the inverse matrix, we should multiply the constant, the constant outside of the matrix into the adjoint method of the matrix A. So we have 4 over 7, negative 1 over 7, negative 5 over 7, and 3 over 7. So let's do example 2. Given matrix A equal to 1, 2, 3, 3, 2, 1, 1, 1, 3. Compute the inverse of A by using adjoint method. So, by using the formula, we have to find the determinant of matrix A and the adjoint of matrix A. To find the adjoint matrix A, we have to know what is the cofactor of matrix A. Okay? So, how to find the cofactor of matrix A? First of all, cofactor is a minor with a sign respectively on every position. So we have cofactor equal to plus, minus, plus, minus, plus, minus, plus, minus, and plus for each of the minor on every position. So find the minor for each. So it will be a bigger cofactor, this area. So here for the first position 1 1, so eliminate delete row 1 column 1. We put the sign first. Eliminate column 1 row 1, so we get 2 1 1 3, right? And then eliminate row 1 column 2, we get 3 1 1 3. Eliminate column 3 row 1 equal to 3 2 1 1. And continue row 2 column 1 2 3 1 3. Row 2 column 2 1 3 1 3. Row 2 column 3 1 2 1 1. And the last row, third row and first column 2 3 2 1. Third row and second column 1 3 3 1. Third row and the third column 1 2 3 2. So now we have the cofactor equal to, so calculate determinant for each position. So we get 5 negative 8 1 negative 3 0 1 negative 4 8 negative 4. Remember, AD minus BC is 6 minus 1, 5, 9 minus 1, 8. Don't forget the sign. 3 minus 1, 2 is 1. 6 minus 3 is 3. 3 minus 3 is 0. 1 minus 2 is negative 1. So, negative 1 of negative is positive. 2 minus 6 is equal to negative 4. 1 minus 9 is negative 8. 2 minus 6 is negative 4. Okay, so we have the cofactor already. So now we can find the adjoint of matrix A and directly find the inverse. So what is inverse? Inverse is determinant 1 over determinant of A. So now we need to find the determinant. So we can use any row or any column. Okay, select one row or one column. Here we will use first row 1 1 1. So, element 1 multiply by the cofactor. We don't have to find out again what is the cofactor because we already find out what is the cofactor from the previous steps. So, use the cofactor we found to find the determinant. So, directly 1 multiplied by 5, 2 multiplied by negative 8, 3 multiplied by 1, add up everything. So, we get negative 8 as the determinant. So, now the A inverse is equal to 1 over negative 8, which is the determinant, and multiply with the cofactor transpose, which is the adjoint. So we transpose the adjoint. What do we get? So this row will be, the first row will be the first column, and then the second row will be the second column, and then the third row will be the third column. The last step that you have to do is to multiply with the constant outside the matrix. So we get the final answer. So we have negative 5 over 8, 3 over 8, 1 over 2, 1. 0, -1, -1/8, -1/8, and 1/2 as the answer for the A inverse. Okay, so let us look at the properties of inverse matrix. As usual, this properties is really important for you when there is a hot questions. Okay, so caution that A inverse is not equal to 1/A. It's not the same. Okay, we don't have 1/A in matrices. So the first properties is A inverse. When we inverse back, it will get itself A. A transpose, when we find out the inverse, we can also find the inverse. We can also find the transpose of A inverse. And the third one, A multiply with B, the two matrix multiply, and then we find the inverse. What do we get as the result? We also can find out by multiplying B inverse with A inverse. So notice the multiplication properties is not the same. AB with BA is not the same. Okay, so remember for the multiplication between two matrices, it's not commutative. So AB is not equal to BA. But for these properties, we can equate it. So A multiplied by B to find the inverse equal to B inverse multiplied with A inverse. And last one, the determinant of A inverse is equivalent to 1/determinant of A. Okay, it's not the same. A inverse with 1/A is not the same. But we can find the determinant of A inverse. It will be equal to 1/determinant of A. It's only for the determinant. Okay, so let's continue with properties of inverse matrix. So note that A inverse is not equal to 1/A. But we know that A multiplied with A inverse, we will get I. A inverse multiplied by A also will get I. Okay? And then AI equal to A inverse I also equal to A inverse. So we multiply any matrix with identity, we will get the matrix itself. Therefore, if AB equal to I, then what it means? This B is equivalent to A inverse, or this A is equal to B inverse. How do we get this? So AB is equal to I. So if we want A inverse, so we introduce A inverse. So because we want to eliminate A inverse on the left side, A and A inverse should be multiplied from the left. From the left, so A inverse multiplied by A. On the right side also we multiply from the left. Okay, A inverse from the left. So A inverse A is equal to I. So I multiplied by B is B. A inverse multiplied by I is A inverse. Okay, the same for B inverse. So we have AB equal to I. Then to find B inverse, we introduce B inverse. But because we introduce B inverse, on the right side we can multiply any side, right? But because we multiply with B is on the right, we need to multiply the B inverse from the right side. Okay, so B inverse from the right side on both sides. So B inverse B, then we will have I. So AI is equal to A, B inverse is equal to B inverse. So we get B inverse equal to A inverse equal to B. Now, it means that if AB equal to KI, a multiple of I, then we can find A inverse, which is equivalent to not only B but 1/K of B. The same as B inverse. So we will get 1/K of A. Alright? So let's do example. So this is example 3. If A is this matrix 2, 5, 1, 3 and B equal to 3, negative 5, negative 1, 2, find AB. Now we want to find the multiplication between A and B. So multiply the AB, we get 2, 5, 1, 3, 3, negative 5, negative 1. Both are 2 by 2 matrix, so they can get be multiplied because it's 2, 2 here. So multiply, final answer should be in 2 by 2 also. So what do we get? We have row and column. Remember, the left matrix should be separating into rows. The right matrix should be separated into columns. Okay. So for 2, 5 multiplied by 3, negative 1. For first row, first column, we have 6 minus 5 equal to 1. And then this one is equal to 1. And then first row, second column, we get negative 10 minus plus with 10, we get 0. Here is 0. And then second row and first column, we get 3 minus 3 equal to 0. And second column and second row, we get negative 5 plus 6 equal to 1. Okay, so the answer is equal to 1001. So what is 1001? It's an identity. So if AB equal to I, we can deduce what is A inverse. So AB equal to I means that A inverse is equal to B. So what is B? B equal to matrix of 3, negative 5, negative 1, 2. So this is our A inverse. So this is by using the properties method. So example 4. So we have a 3 by 3 matrices. So let's find out what is A multiplied by B and hence deduce A inverse. Okay, so I forgot to highlight this word hence. What it means by hence, you need to answer this question relating from the previous question. Okay, you cannot use another method to solve it. Okay, so it must use from the previous question. So the first question we need to find is what is A multiplied by B. Okay, so what is A multiplied by B? So we have a 3 by 3 matrix. So everyone know already how to find the multiplication. So this answer, because it's 3 by 3, 3 by 3, so we will get 3 by 3 as the result. So do the multiplication for each of the element inside the matrices. So we will get the final answer, which is equal to 200,020,002. What it means by this? So this is AB. We have done the first question. The next question, hence deduce A inverse. So we know that AB equal to 200,020,002 means that AB equal to 2 of identity, multiple of 2 of identity. If AB equal to 2i, then A inverse equal to 1 over k of B. So what is our k here? This 2 is equal to k. So A inverse should be 1 over 2b. So what is matrix B? So substitute B with the matrix 1, 1, negative 1, negative 10, 4, 2, 7, negative 3, negative 1. Multiply in. So we get the answer for the A inverse. Okay? Okay. So example 5. Given A equal to 311, 131, 113. Find the value of M and N such that A squared plus MA plus NI equal to 0, where I is a 3 by 3 identity matrix and 0 is 0 matrix. Use this relation to obtain A inverse. So first of all, we need to find the value of M and N such that A squared plus MA plus NI equal to 0. Okay, so what is matrix A? We just need to substitute lah. For A squared is equivalent to A multiplied by A plus M multiplied by matrix A plus n multiplied by matrix I, which is equal to 0 matrix. So what we need to do, we have to do the a squared first. The other is really simple. So for a squared, what do we get is 11, 7, 7, 7, 11, 7, 7, 7, 11. And continue with the next part, m multiplied by matrix A plus n multiplied identity equal to 0. So to find m and n, we can take any two of the elements for the left hand side and the right hand side. So let's say we take the here, because it's one only multiple of m, so we can directly find m, and because 0 n here, so we can ignore n. So if we take the first row second column element, we get 7 plus with m plus with 0n equal to 0, right? 7 plus 1m plus 0n equal to 0. Directly we know that m equal to negative 7. And for n, we can take 1 on the center here, or the first row first column. Anything, any element that you think will help you to find the n. So here we choose the second row and second column. So every element on second row and second column will be 11 plus 3m plus 1n equal to 0. So now we know already what is m, right? So 11 plus 3 multiplied by negative 7 plus n equal to 0. So n is equal to 10. So now we know already what is m and n. Means that to find inverse A, we can find by using this equation, a squared plus ma, which is negative 7a, plus ni, which is 10i equal to 0. Since we have a squared, we can introduce a inverse in the equation. Okay, so a inverse, if we introduce a inverse, we multiply every terms with a inverse on the left side and the right hand side. So what do we get? Here is a multiplied by a inverse. So a inverse is equivalent to I. So we have I. Note that the multiplication of a inverse is consistent whether to the left or to the right hand side of each term. So if we multiply a inverse from the right side, so we have to multiply each term from the right side. Okay, so this is important. So multiplication a squared with a inverse, we get a. Multiplication a with a inverse, we get I. So ai minus 7i plus 10i multiplied by a inverse, we get a inverse. Now we can let a inverse as the subject. The right side always 0. So we have 10a inverse equal to 7i minus a. So a inverse is equal to 1 over 10 of 7i minus a. Now we can replace with I the identity and matrix A into the equation to get a inverse. So what is A inverse? 1 over 10 of matrix 7i, 7 of identity. So we have 7, 0, 0, 0, 7, 0, 0, 0, 7. Minus matrix A, which is 3, 1, 1, 1, 3, 1, and 1, 1, 3. So the final answer we should get is, yes. So multiply the matrix with the coefficient or the constant of 1 over 10. We get 2 over 5 minus 1 over 10. Minus 1 over 10 minus 1 over 10, 2 over 5, negative 1 over 10, negative 1 over 10, negative 1 over 10, 2 over 5. So this is after we deducing from the equation of a squared minus a plus with ma plus with ni equal to 0 matrix. Okay, example 6. If a equal to negative 1, 2, negative 2, 1, show that a squared equal to negative 3i and a cubed equal to negative 3a. Hence, find a inverse and a to the power of 4. So let's say we try to show the first statement first. So A squared equal to 1, negative 1, 2, negative 2, 1. So from the left hand side, left hand side, we start from the left hand side. A squared equal to negative 1, 2, negative 2, 1, multiply with negative 1, 2, negative 2, 1. So this is multiplication between the matrix A. So we get the answer here is negative 0, negative 3, 0, 0, negative 3. Which is, we can factorize out the negative 3, we get negative 3i. So we have shown that a squared equal to negative 3i. And a cubed equal to negative 3a. So what is a cubed? If we know that a squared equal to, negative 3i, means a cubed is equal to a squared multiplied by a. Right? So what we need to do, we can just replace the a squared equal to negative 3i from the previous solution. So negative 3i multiplied by a, we get negative 3a by the use of properties. So we have shown the second statement. Okay, next question, they ask you hence find the a inverse and a to the power 4. So what is a inverse? Since we know that a squared equal to negative 3i, if we want to find a inverse, we can introduce the a inverse in this equation. So if we introduce a inverse for this equation, we get that this is a equal to negative 3i. So the inverse of a is equivalent to this one in the form of ab equal to ki, right? Where k is equal to negative 3. So a inverse is equal to negative 1 over 3 of a. Or another method is we do the multiplication directly. A inverse multiplied with a equal to negative 3 a inverse of I. So we get a equal to negative 3 of a inverse. So a inverse equal to negative 1 over 3 of a. So now we just have to replace the matrix A inside. So we get a inverse equal to 1 over 3, negative 2 over 3, 2 over 3, and negative 1 over 3. Now to get a to the power 4. So we know a to the power 4 is a cubed multiplied by a. So and we know that a cubed is equal to negative 3a. So negative 3a multiplied by a, we will get negative 3 of a squared. So what is a squared? A squared is equal to negative 3i. So what do we get here? We get 9i as the result for matrix a to the power 4, which is 9 multiplied by 1001, which is we have 9009 as the answer. Okay, since we have the word hence, so we need to use the previous question and solution to solve the next question. Okay, so that's all for lecture 3. So now you can find out the inverse of the matrix by using these two methods, the adjoint method and the properties method, AB equal to KI. So thank you.